Okay, so far we have seen different kinds of data mining tasks and their different applications. When it comes to actually applying these data mining tasks on real world data, there's a whole lot of different issues. The real world data consists of many different kinds of formats and many different kinds of issues, and each of them contains their own fine points to consider before we can actually apply the available data mining algorithms in these different real world scenarios. Real world data normally comes in the form of relational databases. Most of the data in the world is used to be present as relational data until, of course, later the World Wide Web started to become very big, and also a lot of data happened to come as multimedia data. So because of the fact that lots of people have digital cameras and so on. Okay, so but relational data itself is very huge, and how do you mine relational data for different kinds of data mining tasks? Let's say association rules, or classification, or clustering, and so on. Basically, you can see very easily that relational data is very amenable to mining for classification and clustering, because it automatically comes in the form of a table of records where there is a set of columns. There are rows and columns. That's what relational database are all about, right? So now one of the columns you can actually treat as a class column, especially if it has well-defined classes. It's a categorical attribute, then it has well-defined classes, and you can try to predict those classes based on the values of all the other columns, all the other attributes. Okay, so that would be a good classification problem. Okay, or you can use these records separately and try to cluster the records based on some distance function. So you need to come up with a good distance function for the current application that you have in mind, and using the distance function you can apply any of the available clustering algorithms to cluster these records. Okay, so now obviously there are other complications to consider, because the relational database normally doesn't consist of just one table. There are lots of other tables which are all interlinked through keys, foreign keys, and so on. Okay, so now in this complex structure, you might need to, before you actually apply classification or clustering, you might need to get all the data that you want for that classification purpose or clustering purpose. You get all the columns that are required from all the different tables, do all the kinds of joins that you want to do, form one nice big table, and then do the classification or clustering. So these are the kinds of issues that you come up with in relational databases. Now in transactional databases, data is very amenable to mining association rules. Okay, so data is of the form where you have different records, and each record is a set, right? So in a transactional database, each record is a set of values. So there are different elements. So it's a set of values. So this could be people who have bought different products from a store. Okay, so now we have seen that this kind of data set is very amenable to mining association rules and frequent item sets. Okay, but obviously you sometimes want to do you want to do clustering or classification on transaction databases. On the other hand, sometimes you want to do frequent item sets and association rules on relational databases. So obviously you need to transform the data sets into the correct format that you need before you apply the correct data mining task. Okay, so then we have issues related to distributed databases. In the real world, many times a database is not just present in one location, but it is present in many different locations. So there might be a business activity at different stores throughout the city, and each of them might have a separate database. Or there might be multiple businesses, different companies, who want to share their data in order to get good mining results. Okay, so now one issue with the latter kind of example is there's lots of privacy concerns. So generally companies don't want to reveal all of their data to other companies. They just want to make their data accessible to some algorithms, and the algorithms will work in such a way they'll only produce rules. Okay, so the data shouldn't actually be shifted from one location to another. It's only the algorithms which work, and the rules that are output might be shifted from one location to another. Okay, so these are some of the kinds of issues that you have with distributed mining. Okay, so the other kinds of things you also need to bother about whether you're going to transfer too much of data from one place to another. If it's allowed that you can transfer data, whether how much of data that you want to transfer, or is it better to do the mining in the different locations separately and only transfer the rules? Okay, so these are the kinds of issues that you have here. Then in spatial databases, a spatial database is a database where one of the columns is actually a spatial column. Okay, so this might be, for example, let's say the address of a person. Okay, so there might be the address of a person. And the address of a person is a location in some space. Okay, so that's the meaning of a spatial attribute. Okay, and any database which has a spatial attribute is a spatial data set. Okay, so now given address column like this, you want to find certain kinds of rules. Okay, things like maybe people who belong to a particular city. So address consists of different parts, right? There's a city, there's a state, and so on. There's a country, and so on. There's a hierarchy of locations in an address. Okay, and you want to find rules of the kind, people who belong to this state, they have this kind of property. Okay, so or people who belong to the city have this kind of property. Okay, so now, or you want to say that people who belong to, let's say, this whole collection of states, which all belong consecutive states, they have certain kind of property. Okay, so when you are dealing with locations or spatial attributes, you have to do all kinds of different tasks. For example, you might want to look at polygons, okay, and talk about the properties of all points within the polygon. Okay, or you want to say that, suppose there's a river, you want to say something about all the cities which are on the bank of that river. Okay, so you need an attribute here called, let's say, adjacent. So you want to find all the cities which are adjacent to the river and mine rules from them. Okay, so these are different kinds of spatial operations that you want to do. So these are the kinds of issues that you come up with in spatial data sets. Okay, so in multimedia data sets, like you might have a collection of songs in your data, okay, in a database, or you might have a collection of movies, or a collection of videos that you have recorded yourself, and so on. And so there's large collection of such data available. Okay, and how do you mine data from this kind of data sets automatically? Okay, so now the key task here is how do you, the kinds of things that you normally want to do is do clustering. Okay, first you do clustering. So you want to find, let's say you have a video, you have one snapshot in the video, and you want to find all the similar snapshots. Okay, so now let's say you want to find all the photographs which have a scenery in the background. Okay, let's say a natural scenery with let's say mountains and so on. Those kinds of photos you want to separate out. Okay, and photos which are taken in cities, you want to separate them out differently. Okay, so you want to have a nice similarity measure, a nice distance metric, and do clustering, which will be able to separate out these kinds of different photos. Okay, so, and there's also classification tasks. Suppose you want to do face recognition, okay, in photos. That's a classification task because you already know that, okay, these are different classes based on the number of people that you have. And given a new photo, you want to put them into one of the different classes after doing face recognition. Okay, so these are the kinds of issues that you come up with in multimedia data sets. Then you have data streams. Data streams are actually, a kind of data set which is actually very huge. It might not be huge in the beginning, but the data is actually coming very soon. For example, stock market data. Okay, in stock market data, each record comes one after the other very soon. Okay, throughout the day there are large number of records being created, and they come as a stream. Okay, and the stream is really so big you cannot store it in any particular place very effectively. So assume that the stream is very huge, that you cannot store it and then mine it. As the stream is coming, you have to mine it on the fly. Okay, so you need special techniques to do data streams. Then you have time series data. Okay, so basically, let's say things like weather prediction. Okay, so you have the temperature of a particular region, and then as the time increases, how the temperature has changed. Okay, and given a time series of this kind, there are things that you might want to do. You might want to study the kinds of trends that are there in this time series. You might want to predict what is going to be the temperature tomorrow in a particular place. What is going to be, so similarly, what is going to be the weather tomorrow, whether it's going to be sunny or raining or whatever in a particular place. These are all time series kinds of applications. Finally, you have in the real world text and web data. So text data in, let's say, digital libraries, lots of digital libraries, and there's lots of HTML documents all over the web. Okay, and this is a huge repository of data. And how do you mine this data effectively? And there are a whole lot of issues, from actually mining content. Okay, so which is actually to basically in text data. Okay, so and then you can use the links that are present in the web, that one document, one HTML document links to another document. How do you use the links to do better mining? Okay, and how do you use the usage? Okay, so people who actually use these websites, how many people have seen this particular website? After seeing this website, how many people shift, okay, move on to this other website? Okay, so things like that. So basically the usage of these websites. Okay, so there are different kinds of data that is available. So how do you mine these different kinds of data on the web or in text digital libraries in order to get interesting kinds of patterns that are very valuable to the users? Okay, so this is all that you have different kinds of applications on real world data.